welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Arabic College, University of Delhi. So you remember when we started with the topic of database modeling, we have started with two terms. One was entity relationship diagram and another one was normalization, and I have told you that normalization I will be covering in our upcoming lectures. So yes, you guessed it right. Today is our the first lecture about normalization. So basically, when we talk about database modeling, we have seen ER diagram. Then in that sequence, we have also seen enhanced ER diagram or extended ER diagram. So these are basically tools through which appropriate modeling can be done. Now, why are we insisting on the appropriate modeling, or why are we insisting on these kinds of mechanisms? That is why, because our we can say agenda behind using this database management system is that we want to store the information without the I cannot say without the redundancy, because elimination of redundancy completely is actually not possible. So I would rather prefer to say storage of information without unnecessary redundancy. So there should not be redundancy which can be avoided or which is not mandatory, but there are some situations where you have to have some redundancy. So that unnecessary redundancy we do not want. Apart from that, the agenda behind using this database management system was that it must allow us to retrieve information very easily. So whatever information we are looking for, that information should be retrieved easily. So for that we have gone through the modeling, and we have seen the first tool for modeling, that was entity relationship diagram, which was accomplished by designing the schemas that are appropriate. So when I am saying the ER diagram was accomplished by designing the schemas that are appropriate. Now what is the we can say characteristics, or what is the definition of the term appropriate here in this context? So in short, I can say these schemas should be there if, in appropriate normal form. So in appropriate normal form, what does it mean? That we will see here, please recall the university database schema, which we are kind of using for using since long for many examples. So I am just trying to recall that schema here. So one relation classroom with building, room number and capacity, another one department with department name, building and budget. Then we have course with course ID, title, department name, credits. Then we have instructor with ID, name, department name and salary. We have section with course ID, section ID, semester, year, building and room number. Then we have time slot ID into that also. Then we have teachers with ID, course ID, section ID, semester, year. Student with ID, name, department name, total credits, takes, ID, course ID, section ID, semester, year, grade. Advisor, SID and advisor with two attributes, which is SID and IID. Then we have time slots, which is time slot ID, day, start time and end time. And finally, we have prerequisites relation, which is about course ID and prerequisite ID. So I have just given you a glance of what the whole schema of that university database. So now when we try to model or try to design these schemas, or if we want to try we want to transit these schemas into actual databases, there can be various design alternatives for which we need to take a call. So one design alternative could be, should we have larger schemas, or another design alternative in lieu of it, it could be, should we go for shorter schemas. So in order to kind of understand the term of normalization, in order to understand the platform, or in order to build the platform for this normalization, let us try to see these some design alternatives, and then we will see how these are connected to today's topic, which is normalization. So, for example, there we have the instructor and the department, the two schemas. So, here the instructor is having ID, name, department name and salary, and apart from that we also have one more which is department. So, department is also having its uh, features or its attributes as in department name, building and budget. Now, when we are picking the design alternatives of having larger schemas, let us try to combine these two schemas of instructor and department, and instead of having the two separate, let us have one common, and that instructor department is having ID, name, salary, department name, building and budget. So, basically we have combined the we can say attributes of both the shorter schemas, and we have we are having a larger schema here. So, basically how this larger schema is being generated as of now, this is actually a result of natural join on the two relations, which are instructor and department. So, on the instructor and department, when we are performing a natural join, we are going to have this instructor department. So, the situation here is instead of having instructor and department, we have one instruct department with these attributes as ID, name, salary, department name, building and budget. And here is the we can say one snapshot of that particular new larger schema of uh, instructor department. So, this seems fine, as unless we go into this row by row or every piece of data we are going to drill, this seems fine. Now, but there are couple of problems with this kind of approach. Now, what are these problems? So, the first problem here is about redundancy. Now, please observe that what is given on the screen. So, here you can say this rows of which is 45565 cards, then 75,000 as the salary belonging to computer science department, and the computer science department is being held in or being hosted inside the Taylor building, and the budget is let us say whatever it is 100,000. And similarly, this kind of information, which is the computer science department is being hosted inside the Taylor building and it is having the budget of 100,000, is actually, you can see this is being repeated quite a number of times with the row number 4, with the row number 5, then we have row number 7, and then we have also row number 9. So, apart from this 3, 7 and 9 are having the professors from computer science, and so is the information of the computer science department, which is the building and the budget, is repeated. Similarly, one professor came from electrical engineering department, that electrical engineering is also hosted inside this Taylor building and having some kind of budget. So, that is also kind of, we can say, being repeated if we have some more electrical engineering professors here. So, for the time being, let us focus on the computer science example. So, 3 professors from computer science here in this table. So, 3 times the building name and the budget allocated to the computer science department is being repeated. So, one thing, this is actually an we can say unnecessary redundancy, and this unnecessary redundancy has to be avoided, where here we are doing that we are repeating the department information of building and budget once for each instructor and the department. So, for example, one department is having, let us say 20 instructors. So, the information of building and budget is going to be repeated 20 times. So, that is something unwanted here. Please recall the original design in which the instructor and the department was separate. So, the amount of budget was stored exactly one when we were talking about the department, and so is the, we can say, building, we can also do that. So, one thing is in case of these larger schemas, one problem is the unnecessary redundancy. What is the other problem? As I have mentioned that there are two major problems here. Another problem is looking at this particular uh, table, we can say, or looking at this particular relation. If you can see, if we want to create one new department and we do not have any faculty deputed or any faculty appointed for that particular department. So, what are we going to store here? We will be storing the department name, we will be storing the building, and we can also store the budget. But what about the ID, name and salary? So, this ID, name and salary, three we can say pieces of data or three attributes here will go blank, and we need to administer the null values here. So, administration of null values is actually, one is inclusion of null values is a problem, and then proper administration is another issue. So, combining the two smaller schemas into a larger one is going to give you these kinds of problems. So, one was the unnecessary redundancy, and another one was if we want to enter a particular record, or it could be otherwise. Let us say for example, we have deputed one professor who is having double PhD, let us say one in commerce and another one in computer science, and we can take him or her in either for the computer science or the commerce, and but as of now yet we have not decided. So, while entering the record, we need to assign the department, then the budget, and the building has to be specified. So, these kinds of problems will be there. Now, can we have is it necessary that always combining the two smaller schemas is going to result in a repetition? So that is a question. So, can we have a combined schema without repetition? So, yes, this is also possible. Let us try to take an example in which we will be combining the two schemas, the two relations. One is section class, which is about this class having section ID, building, room number, and another one is the section which is having course ID, section ID, semester and year. These two schemas we can combine into one relation, and that relation will be having course ID, section ID, semester, year, and corresponding to the section ID, building and room number will be there. So, here in the tables or in the relations, if you can see what data we have stored in this, in these section and class, the individual relations, there is no such kind of repetition which is going to happen in case of this combined schemas. So, the one thing which we can certainly say is not all combined schemas results in the repetition of information. So, if we are going with larger schemas by combining, then we have to be then we need to check it reasonably that whether it is going to result in the repetition or it is working without redundancy. Both can be the cases. Now, actually the situation is, can we avoid this repetition of information problem which we have just seen? So, yes, one way to avoid, or we can say the only way to avoid the repetition of information problem is we can say is decomposition. So, let us decompose the standard that combined schema into the two schemas and go back to our uh, original design, we can say. But while decomposition, we also have to be very careful. Why? Because not all the decompositions are good. Suppose we have one this thing, one particular relation which is the relation of employee having ID, name, street, city and salary. And let us say we are going to decompose this relation into two. One is the employee 1 having ID and name, and another one is having employee 2 which is having the name, street, city and salary, which is the first two and the last 4 in another. So with this, how can we do that? So for example, let us see here on the screen, we have employee, and that employee is actually divided into or decomposed. Decomposition is actually the proper term, is decomposed into the two, employee 1 and employee 2. Employee 1 is having ID and name, and name, street, city and salary is having enclosed in employee 2. Now here what is happening? We have one employee named as Kim, uh, and this name is actually being repeated. So we can have a common name, but these two Kims which are given in the employee relationship relation, which was the combined one, those two rows, if you can witness here, are having ID 57766 and 98776. So these are, certainly we can say, these are two different employees whose name is similar. Street is definitely different, city is different, and so as the salary. And when we are going to decompose these into two, we are going to get ID and name, and then name, street, city, salary in another. Now in order to have a combined schema, I have just told you that we will be performing a natural join. Now see, if you perform a natural join here, each and every the total, so if we are talking about natural join and we are looking onto only onto the rows of these two employees which are named as Kim. So two records from employee 1, two records from employee 2, Cartesian product will be taken, and finally we will be having 4 records. But these 4 records are having some wrong information. So for example, if you can see, the first row is fine, where the Kim is having ID 57766 with city as Matin, Parriage at the the street as Main, city as Parriage, and the salary is 75,000. While the second row, which is followed immediately, which is 57766, the name is Kim, city street here is North, and the city is Hampton, and the salary is 67,000. There is no such there is one record, yes, which is being placed in the original one, but that is not having the ID as 57766. So here, instead of getting two records corresponding to these two employees having the similar name Kim, with the help of natural join, which is a process to combine the decomposed schema, we are getting 4 results. So obviously 2 of these results are wrong. That means we are actually we can say we are losing some information, because the resulting tuples which are formed from the decomposed schemas, they should be get into, or they should regenerate the original tuples using a natural join. So have more tuples but less information we are having, because the information which is repeated is actually a wrong information, we can say, because certain city, street and salary pertaining to someone named Kim is not applicable to the another one, and we are unable to distinguish which of the Kim we are talking about. So here we can say the decomposition is unable to represent the certain important facts about these universities employee, and clearly we would like to avoid such decompositions in which the facts are not being represented. So when the facts or the information are not being represented, that means we are losing some information. We call that as lossy decomposition. Now can we have some lossless decomposition in which there is no loss of information is happening? So the answer is yes, we can have that. Let us take an example here. So let's say we have R as a relation schema with R1 and R2 are going to form a decomposition of R, and we are going to regenerate, that is R can be regenerated by union of R1 and R2. Now, how this decomposition can be a lossless decomposition if there is no loss of information by replacing R with these two relation schemas R1 and R2. So, formally we can say these symbols, I am sure that you are aware of, that this pi, which is about the kind of we talk about when we talk about selection and projection in the relational algebras, we use these symbols. So, we can say if we are going to have one the original relation schema R by combining or by taking the union of R1 and R2, if we are going to have it, then your decomposition is lossless, and conversely if your decomposition can be called as lossy when you whatever result you are going to get by combining the R1 and R2, that is not properly R, but that is a subset of R. That means some of the information is missing in the result of the union. So, that decomposition is called as lossy decomposition, for which the example we have just seen. So, for lossless decomposition, let us try to see how in what kind of scenarios we can have a lossless decomposition. So, here is a relation R with A, B, C as the attributes. A is having two values alpha and beta, B is having 1 and 2, and C is having two values A and B. Now, if we want to decompose this into two pieces, one is having A and B and another one is having B and C with two rows or two records in each. When we want to combine them, we are going to have our original relation even if we combine the two decomposed relations of AB and BC. So, these type of examples are there in which the decomposition is lossless, we can say. So, here we have seen some of the situations in which why do we need data modeling. ER diagrams we have also we have already seen, and for building the platform or the base of normalization, presently we have seen the two terms. One is the lossless decomposition, another one is the lossy decomposition, and these two terms actually comes from the fact that what kind of design initiatives we are going to opt for, whether we are going to opt for the larger schemas in which the relations are combined or we are going to have the smaller schemas in which the relations are we can say decomposed. So, while decomposition, we need to be very careful that the decomposition should not be a lossy decomposition. That means it should not result into we can say the loss of the information. So, how this is we can say connected to normalization. So, in this process of decomposition or kind of we can say performing the natural join, what side effect we had was the redundancy was the redundancy was introduced, and another one, data integrity was lost, because recall that example of Kim, for the Kim, apart from these 4 rows, 2 rows were actually having incorrect data if we talk about the combined naturally joined relation. So, what is actually happening here? Redundancy has been introduced and integrity has been lost. So, here comes the process of normalization, which is there to eliminate the data redundancy and to ensure and enhance the data integrity for a table. It is actually a process which is going to help us to organize the data in the database. Also, it is not a one step process, it is a multi-step process that sets the data into tabular form, removes the redundant data from that relations. Now, this actually in order to set the data into the tabular form, normalization organizes the columns and tables of the database in order to ensure that all the integrity constraints are properly executed on the basis of their dependencies. Now here we have a new term, that is dependencies. I will be taking this dependency in our upcoming lecture. But before, let us try to explore normalization more. It is actually a systematic technique of decomposing the tables to eliminate the data redundancy or repetition, what we call, and undesirable characteristics. What are these undesirable characteristics? Is we can have anomalies in insertion, we can have anomalies in deletion, we can have anomalies in updation also. So, all these undesirable characteristics should be we can say eliminated. Data redundancy can be data redundancy should be eliminated. Also data integrity should be ensured and enhanced. So, basically we actually need a relation R, which is, we can say, is in a good form. So, good form means uh, lossless decomposition should be there, then no redundancy should be there, then integrity should be maintained, and so on and so forth. And this normalization is based on the two terms which we can say is functional dependencies and multi-valued dependencies, which we will be covering in our upcoming lecture. So, basically a properly normalized database must have the following characteristics. We can have scalar values in each fields, not the non-scalar or non-atomic values. Combined values are not allowed. Redundancy should not be there. Null values are actually a challenge to handle. So, minimal values of null values, minimal use of null values should be there, and minimal loss of information should be there. All these are characteristics of we can say a normalized database. So, in our upcoming lecture we will be looking into the kind of more specific requirements of these normalization and what all levels of normalization are there. But yes, one thing is sure, that number of tables in a normalized database will be increased, or it is most probably likely to increase. Complexity also we can say yes, it can increase. This comes under actually debate, but yes, redundancy is definitely going to be we can say reduced. So, in this lecture we have seen our initiative of normalization, that why normalization is necessary, and what are the effects if we do not have a normalized database. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you soon in the next lecture. Till then, take care. Goodbye.